Okay guys, this is an introduction to the GPS FSK encoder. What this device does is it takes the GPS coordinates that are output from this Garmin GPS in a serial data stream and converts that serial data into tones where it's played out on a speaker. And then those tones coming out of the speaker can then be played across the radio, just holding a regular microphone up close to the speaker, and the coordinates will come out at the other side. It has inside the box, it has an Arduino used to act as a baud rate converter, and it has an MX614 chip to do the data to tone encoding, and a LM386 chip as an audio amplifier to drive the speaker. It has a volume control and an on and off. I'll turn it on here and give you a demonstration of what it sounds like. And each one of those bursts of sound there is 1200 baud data, which is two tones switching back from 1200 and 2200 hertz back and forth. It started out as a direct device to connect directly to the radio, and it can certainly do that. But on a whim, I just happened to wanted to see what would happen if I hooked it up to an audio amplifier, how much it would or would not work. I was really skeptical and didn't think it would work very much, or it'd be just extremely rare to get it to work. And I was fairly shocked about how accurate it was and how consistent. And once you got the volume and everything right, that just getting the microphone anywhere near it, you would get excellent results at the other end. Results that were the same as if I had it connected directly to the radio. So this makes it a completely standalone device. I can replace the 12 volts here with a battery pack and have it portable, so that I can play with a portable as well, a portable radio. So anyway, I'm going to get into the schematic of it, and then I'll actually take this device and show you it in use, going between two radios to output my GPS coordinates. So stand by for that. Okay guys, I'm here at the radios and I'm going to give a demo of how they work. I got the GPS FSK encoder here, and this is going to be the transmit radio. I have the receive radio over here connected to my laptop that's running hyperterm. And to start off with, I'm just going to do some transmission to show you how I'm getting the sentence over here on my hyperterm, and then after I do that, I'm going to flip over to the Spectrum Lab software and show you how the location actually pops up there. So stand by. The volume is loud. It needs to be loud, not obnoxiously loud, but loud enough. So I'll do this, and you'll be able to see it come across on the screen here. So stand by. And there you go. We got 5 or 6 good sentences right there in a row. There is a definite curve to where if you don't have the volume loud enough, you just get nothing but gibberish. But once you get the volume loud enough and get the microphone relatively close to the speaker, it just takes over and is steady as a rock after that. So let me pull up the Spectrum Lab software and give you another show, so stand by for that. Okay, now I've switched over to the Spectrum Lab program here, and I have the GPS receiver function pulled up. And as you can see in my configuration, I have the COM1 and 1200 with decimal degrees selected. And so all I got to do is come over here to my position, and I'll wait for the incoming data packet from my radio. So let's come over here and fire it up, and I'll key it up and wait till I see my position come up. Okay, and there we go. There's our position, and it was not too bad. Just a couple 3 tries. So you just got to hold up there, and it actually gives you the same pause no matter if you do a direct connect or not. But so okay, there's a demo of it working, and now we'll go to the actual detailed drawing and go from there. So stand by. Okay, let's go over this circuit. I've been over the Garmin and the Mega Pro Mini and the MX614 in previous videos, and when I got finished with the last one, my output of the MX614 was going to my microphone input of my radio. So I've modified that circuit now to where on my output of my 614 I'm now going into an LM386 N-4 audio amp. Make sure you get the N-4s. They're the actual 1-watt versions, and they're only like another $1 more. They're like $2 a piece. They're really cheap. But and make sure you put the accompanying circuitry around to make sure it's nice and stable. I'm using a 7809 voltage regulator on it just to keep it nice and pure. I found the audio, the more stable the audio, the better it performs. So this makes for just a really smooth, rock solid tone coming out. The volume adjusts really well, and the even at the lower volume, there's no hiss or anything at all. So I'm real happy with that. And I just put the on-off switch here to the 9-volt regulator, so that the no reason to run the amplifier chip until you need it. The GPS itself in the MX614, it runs the entire time you have it plugged in through the 7805 over here. It's only like 150, 140 milliamps, so it's very trivial. Even when the speaker is on full volume, it's only a couple hundred milliamps. So very little current draw. Easy to put on a battery pack. It'll last for quite a while. So anyway, here's the final circuit, and each speaker microphone thing here is going to be its own unique critter as far as how loud and how close, etc., etc. I should say, without a doubt, this absolutely needs to be an analog radio. The digital radios, no way, no how, they're passing tones like that. You would think the digital radio would be easy to pass data across it, and it's the exact opposite. They talk about being able to put data across, but no one's actually done it yet and has something out there that's a viable solution. So all they have is their over-the-air reprogramming and stuff like that, but nothing using it as just a straight transport mechanism for serial data. But anyway, this is the I think this is going to be the last iteration of it. I'm still going to try and get the board in a with that the little program that lets you fabricate your own boards. So going to try that to be able to get it on a smaller package, so I don't have to hand assemble it. But anyway, this is it. This is the final package. So Hope you guys get a chance to put one together yourself and give it a test out. I figured there were a lot of people out there that didn't want to have to interface to the actual radio. That would be a kind of forbidden thing for them. So this is completely look, Mom, no wires. So all right, that's it. We'll talk to you soon.